Okay, so now, as I spoke to you just a little while ago, we get to use our factoring, where we're no longer just factoring, we're actually applying that concept to doing things. And the next section, like I said, we'll do word problems. In this section, we're just getting started. So in this section, we're going to be solving some equations, and those equations are going to somewhere involve some factoring in them. So you get to see what that looks like. Now, everything you've learned before is going to be used here. So I'll ask you the same questions when we get to the point of factoring. I'll ask you things like, is it in order? Is the first term positive? Does it have a GCF? How many terms are there for grouping, diamond problem, or difference of squares, difference of cubes, sum of cubes? All those things should be in your head at some point right now, right? So at some point in this problem, we will get to those concepts. The idea is, how do you get to those ideas? How do you use factoring? And it's honestly not that hard. Today should be a little bit of an easier lesson because I've already built up your foundation of factoring, which is a really good thing. So one thing I need you to recall is this. Every single time that we have a quadratic equation, have you heard that word before? Quadratic equation. You might have, and I forgot what it means. A quadratic equation just means that the largest power is 2. That's it. So linear means the largest power of the variable is 1. Quadratic means the largest power of the variable is 2. So all the stuff that we've been most of the stuff that we've been factoring, all of your diamond problems, except for those special cases, those have all been quadratics. Usually a 3-term polynomial, if it has like x squared, x in a number, without an x to the third or anything, that's a quadratic. So when I say quadratic, so every quadratic, can be written like this. And you've seen this before. You've seen the ax squared plus bx plus c. Do you follow me on that? Now, this should look familiar, right? That's how we find our A and our B and our C for our factor and diamond problems all the time. And if we don't have an A, it's a shortcut. If we do have an A, that's the grouping that we have to do. Or I did actually give you a shortcut in section 6.5. So for every quadratic, listen carefully, every quadratic you can write it like this. Do you believe that? That means every quadratic equation, what separates an expression like we have here from an equation? That's right. So every quadratic equation can be written as ax squared plus bx plus c equals 0. That's the idea. Every quadratic equation in the world can be written just like that. And if you get that, this is basically what we're doing today. We're trying to make our equations look like that. Does that make sense? Okay, so this is called standard form, by the way. So here's what I'm going to give you a note. I'm going to actually write it out for you because it's pretty important. So your note for today. Here's what I want you to write down. Every time you have an equation with a power 2, every time you have an equation with a power 2, that means it's quadratic. That's all that means. Get everything to one side in order with the first term positive and 0 on the other side. Does that sound familiar to you a little bit? It should, because I've said it at least like 100 times. Get everything in order, first term positive. This time though, we're just putting 0 on the other side. That's the idea. So every time you have an equation with a power 2. And all that means with a power 2 just means that it is quadratic. Here's what your goal is. Your goal is to move everything to one side in order with your A positive and 0 on the other side. Everything to one side, this is what I want you to know. One side with A positive and 0 on the other side. you can do that every time, if you can recognize that, if you can recognize, hey, power 2. Power 2 is, what's the special word for power 2? No, I'm sorry, one more time, it's on the board. What's a special word for a power 2?
Quadratic.
Quadratic expression, or if you have an equal sign, it's a quadratic equation. If you can recognize you have a quadratic equation, and you're good with this, you get everything on one side, in order, where your first term is positive. That's what that means right here. That's exactly the same method that we had for factoring. Do you understand what I'm trying to get at here? The reason why I taught you all this stuff before was not for nothing. It was that when we get here, finally, we're able to use it. Everything in order, A positive, first term positive, that's your A positive, and then 0 on the other side, then we can factor. Quick head nod if you're okay on seeing the connection here. Okay, good. Now, there's one more thing we have to discuss before we get into actually doing these problems, and that's a very important property. You've probably heard it before, you might have even used it before. It's called the zero product property. It's a very intuitive property, but I want to make sure I at least mention it here. So, the zero product property. Here's what it says. I'm going to say it out loud for you in English. I'm not going to write anything because it really is that intuitive. Here's the idea. What's a product, by the way? Okay, and so the zero product property says this. Suppose you have two factors which are multiplied together, hence the name product, okay? Two factors or more factors that are multiplied together, and that product equals 0. Hence the name zero product, and the property follows. So we have these factors that are multiplied together, and the answer is 0. The product is 0. Here's my question. What do you know about either A or B or both? What do you know about either A or B? Can you get a product of 0 without one of those numbers being 0? No. There's no way that's happening. So if you have A times B equals 0, either A is 0 or B is 0. That is what the zero product property says, and it doesn't just stop at A and B. If you had like A times B times C times D, any one of those things could have been 0. They all could have been 0, and those would still make that product equal 0. Show of hands if you understand the concept of zero product. It's pretty intuitive, right? It says, hey, if you're multiplying stuff and it gives you 0, at least one of the things you're multiplying is 0. That's the idea. Now, here's how we use it. Here's how we use it. Firstly, tell me, is this an expression or is this an equation? You should know right off the bat just by looking at it. How do you know? Notice zero product property works with equations. Oh, look at that. Wow, how about this? Zero product property works with equations where what number's on one side? Does a zero product property work if that number's not 0? No. For instance, if this is 12, don't write this, please, for goodness sakes, don't write this, okay? If this is 12, does it mean one of those numbers is 12? No. One could be 3, one could be 4, one could be 6, one could be 2, or in other words, every factor of 12, even fractions of 12 would work. The only time this actually works is if this number is what? 0. That's what's called zero product property, okay? Do not ever try to do this without that number being 0. Is that understood for everybody? I'm going to say it one more time. It's so important. Do not ever try to attempt the following if that number is not 0. Is that clear? So, but here's what it says. If you have an equation, and if you have 0 on one side, which is exactly what we're trying to do right here. We're going to be using this. We want 0 on one side. Why? For the zero product property to work. If that happens, though, check it out. You believe me that A times B equals 0 means A is 0 or B is 0. Do you believe that? Yeah. Well, look here. Do I have two factors that are being multiplied together that's giving me 0?
Yes.
Right in here, that's a multiplication. So here's where we make the extension of this concept. If A equals 0 or B equals 0, well, that means that this factor had to equal 0 or this factor has to equal 0. Or this factor has to equal 0. In fact, Either one of those being 0 is going to make that true. I want to see if you see the connection between the zero product property here and the example I've shown you. Show of hands if you do see that. So we have these two pieces, they're multiplied together, they give you 0. Either one of those pieces has to be 0. Now, here's the point. Can you solve this? You better. If you're in this class, you better be able to solve that. Get x by itself. Get rid of the 1. How do you do it? Yeah. By the way, at this point, these should be really, really, really easy, okay? There's not going to be any like stumpers or, oh my gosh, how do we solve it? They should always be pretty easy. There will be at most 2 steps. At most, you'll either have to add or subtract and then divide. That's it. Because they'll all be linear for you if you start with the quadratic. How much is it?
-1.
And what else?
-6.
If I add 3. Now here's my question. How many solutions do we get? 2 solutions. In fact, both of these numbers make this work. Check it out. If I plug in -1, y'all better be able to answer this for me. -1 plus 1 is how much? 0 times, I don't even care what that is. What's the answer? Okay, plug in 3. This is going to give you 4. What's 3 minus 3?
0.
What's 4 times 0? I don't care what this one is. If one factor equals 0, the answer is correct as far as being equal to 0. That's the idea of zero product property, and that's what we're going to be using here. You guys want to try a couple more just to really get our feet wet in this? Okay. You know what? Just to make sure that you got it, I'm going to do one more example with you, and then I'll give you 3 to do on your own. Okay, so make sure that you actually have this. So here's our final example together, and then we'll actually start moving on and doing some stuff with it. Y times the quantity y minus 7 equals 0. Here's my question. Does the zero product property apply? And how you answer that is, do you have a product, and is it equal to 0? Do you have a product?
Yes.
Is it equal to 0? So we can use the zero product property. Now, what you got to be good at is stating that every factor is going to equal 0 here. The first factor here was x plus 1. Second factor was x minus 3. What's the first factor here?
Y.
Because I asked. I know, it's not funny anymore. I get it. My bad. Okay. So the first factor is y, and this is what a lot of students forget. They go, oh yeah, it's only the stuff in parentheses. No. No, the zero product property says take every factor. If there's a multiplication, that's a factor. And put it equal to 0. In fact, this is an even easier problem than before. One of them's already solved for you. If y is 0, multiplied by anything, I don't care what it is, you're going to get 0. What's the other one that we're going to have? Yeah, and we can just solve that by adding 7 to both sides. Do we still get 2 solutions?
Yes.
Yeah. For every factor that you have, you will have at least 1 solution. Gives you something. Are you ready to try a couple on your own?
Mm-hmm.
Is this pretty straightforward to you? Yes. Compared to all the factoring we've been doing, this should be the easy part, okay? So let's try just a few. I want you to look to see if the zero product property is going to apply. What that means is you have a product and it's equal to 0. If it's not 0, can you do this stuff?
No.
Everybody, if this is not 0, can you do this stuff?
No.
Okay, so you got to have that. But once you do, then apply the zero product property. You know what? I'm going to write one more over here for you. So I want this and this and this. This one will be a little bit more of a challenging one. These ones, I expect no problems. I think you can do this almost in your head probably if you wanted to. Show your work, but I think you probably do them in your head. This one I want you to, maybe a little challenging, but you should still be able to get it. Does the zero product property apply in those three examples?
Yes.
As long as you got stuff multiplied, not added, subtracted, okay? And you have 0 as your answer. That means the zero product property is going to work. So here we go. If you have, I don't care how many factors you got, if you have a product that's equal to 0, all you have to do is set each of those factors equal to 0 until you run out of factors. So in our case, we have x plus 9 equals 0. We got x minus 2 equals 0. If you were to solve this, how would you do it? Yep, subtract 9. Did you guys remember solving equations? We just undo everything around the variable. We should be pretty good at that at this point. If we subtract 9 from both sides, remember what you do on one side, you got to do the other. We get x, shoot, I can't run out of room. We get x equals negative 9. If we add 2 to both sides, we're just undoing everything around the variable. We get x equals 2. The other one, we have x and x plus 3, was it? How many factors do we have here?
2.
Set both of them equal to 0. X equals 0, that's kind of an easy one. And then x plus 3 equals 0. Yeah, let's just subtract the 3. If we do that, we're going to get x equals negative 3. And those are our two solutions. Could you check them? Actually, really easy to check. Just plug them in and make sure that they actually give you a 0 times something. If they do, then you know that that product has to be 0. Now this last one. The zero product property still works. I have a product and I have a 0. What it's going to take is us setting each of these factors equal to 0. So 3y equals 0. Did you guys see where I'm getting the 3y equals 0 from? It's one of the factors. Just like it was the x here equals 0, the 3y has to equal 0. It's one of the factors. You set all the factors equal to 0. I don't mean you set the 3 equal to 0. Okay, you take the whole piece that's being multiplied, the 3y. And then we'd have 2y minus 1 equals 0. Put your hands, feel okay with that so far. Now, first one, can you solve for y?
Yeah.
How?
Divide by 3.
Is it okay to divide 0 by 3?
Yeah.
Is it okay to divide 3 by 0?
No.
Okay, so dividing 0 by a number, fine, that's okay. You get how much?
0.
That's right. Dividing by 0 is never good, that's undefined. So we won't have that case here because you won't have a 0 over here, okay? So you'll not get undefined answers with these polynomials. You can't get that. So don't ever get 0 divided by a number undefined. It's just 0. If you have a 0 divided by a number, you get 0. Here, solve it. What do you do?
Add 1.
Is it okay to get fractions as an answer?
Yes.
Of course. If we divide by 2, y equals 1/2. Don't be afraid if you get a fraction. That can happen a lot. In fact, we have more fraction answers than whole number answers in actual math. Show of hands, feel okay with the idea so far? Okay, that's all I'm going to give you as far as zero product property by itself, because now the idea is, can we use it? Can we use what we did with factoring, combine with this idea of the zero product property, and get answers to equations? And that's what we're going to do right now. So, take a look at the board. We got y squared minus 3y minus 18. Hey, if I gave that to you, on a test and said factor it, what's the first thing that you would check? Ah! Let's see. One side. I forgot in order, didn't I? Well, you get the idea of in order. Next thing you check is if it's positive. Exactly what we have written down. On one side. Well, there's not a side yet, but we would check in order. We would check to see if A is positive. We check for a GCF, and then we start factoring. That's everything I'm asking you to do here. The only difference between what we've done and what we're about to do is this right here is called an expression. This right here is now an equation. So if I give you that on a test, please notice that there's nothing different about what you've been doing and what you're going to be doing. It's just that you have to check a couple things first. So number one thing, check this stuff. Is everything on one side with 0 on the other side? I'll give you a little hint. The reason that clues me into checking that is that we have a quadratic. Verify that that's a quadratic. Quadratic means the largest power is 2. Do you guys see the largest power of 2? That's quadratic. So quadratic says get everything on one side. Is it? 0's on the other side. Is it? Okay. Is the first term positive? Is that positive? It's the same stuff we've been checking. And now we start factoring. So do we have a GCF besides 1? No. It's the same stuff, guys. How many terms do we have?
3.
What do you use for 3 terms?
Diamond.
Oh my gosh, it makes sense. Now, with this diamond problem, will you be able to do a shortcut?
Yes.
Your A is 1. You can do that. Factor it. I'm no longer going to baby you through factoring, okay? You got to have it down to this point. So factor it. Did you factor it? Yes, no? If you're going to do the diamond problem, we've got a -3 and we've got a -18. Two numbers that work there are, it's got to be 6 and 3. It's got to be a -6 and a +3. Can you verify that for me?
Yes.
Also, what variable do we have here?
1.
Then when we do our 2 factors, what variable are we going to have here?
Y.
By the way, do you recognize the shortcut does work? I don't have to do the extra stuff. If you did, if you wanted to, you could, okay? There's nothing wrong with that, just going to take you some extra time. I'm trying to give you a shortcut here. Shortcut on diamond problem is, hey, if there's no A here, these numbers finish off our factors here. Show of hands if you got that so far. Now there's one really important thing that I'm missing on the board right now. What is it?
Equals 0.
Yeah, that's important. You see, before, we were just factoring. If I ask you to factor, that's right. That's absolutely correct. Am I asking you just to factor now? No, I'm asking you to solve. And so if we have this equals 0, oh my gosh, it's exactly why we did this stuff. Do you guys see the similarity in what we just did? So I started you off with stuff like this. It's easy. Set each factor equals 0, solve it. But now we're using 2 things. We're saying, hey, factor it so that you can use the zero product property. I'm going to ask you a question right now. Does it make sense why I'm having you get everything to one side and 0 on the other side right now?
Yeah.
If you're going to factor, you have to have that because of the zero product property. If this is any other number besides 0, this stuff does not work. So before you start to factor, before you do anything, follow this. Get everything to one side. Get it in order. Get your A term positive, and then factor. If you can do that, you're good to go. It's really just a small extension of this concept. We are going to practice a few more. I want to make sure that you're good on this. Because this is really this whole section. If you understand this idea, you pretty much understand the section. Okay, I'm actually give you 2 to do. One of them is going to be very much like the one you just did. One of them is going to be just a little extension. I want to see if you can manage it, okay? Let's try that one. And this one. Oh, you know what? I guess we better finish the problem, huh? I got to talking, I didn't even finish the problem. If you do this on a test, I give it to you wrong, so I guess I messed up on that one. Do I want you to stop right here?
No.
No, I got all involved in talking about the zero product property. We didn't actually do the zero product property. So from here, you finish off like you did over here. So check the 0, factor it, keep the 0, and then apply the zero product property. That's why we had the 0. So for us, we would have y minus 6 equals 0. We would have y plus 3 equals 0. And then we solve it. If you add 6, you get 6. If you subtract 3, you get -3. And those are our 2 solutions. And here's what's interesting about this. Where you need to check these, are you listening right now? Where you need to check these is not here. Don't check them here. Because this was work that you did to get that, right? What if that work is wrong? It's not going to show you if you're right or wrong. Check these answers here. I know it's a little bit more time consuming, but that will kind of double check what you've done. It will say whether or not your factoring's right and whether or not you did this right. So check these answers, not where you factored it, but right at the very beginning. Quick head nod if you understand that. You always check at the very beginning of your problem, not in the middle steps because we made a mistake getting there. You guys okay on the +6 and the -3? Cool, and you would definitely check them up there. Okay, go ahead and I want you to do these 2 problems. Remember that first thing you got to do is make sure everything's to one side and in order. Then I want you to factor and use the zero product property to solve. I'll be walking around for a couple minutes. If you need help on this, now would be a good time. Okay, I gave the second problem to you as kind of a challenge problem. I know that we haven't done anything like this before, okay? So if you got it, great. If not, don't worry about it right now. I'm going to go through it right now with you, okay? First thing, we check the first one. The first thing that we do when we're solving any equation that is a quadratic is, well, you better verify it's a quadratic. Is that a quadratic equation?
Yes.
Yeah, quadratic equation, sure. Do we have everything on one side, which means 0 on the other side?
Yes.
That's your number one thing. Okay? If you don't have that, listen, if you don't have it, you make it be that. You can, because every quadratic equation, you can make it fit this model. We were talking, opening of class, we talked about that. Next thing you check for, is it in order? Let me make this so clear to you, okay? In order for you to factor, this must be in order. You have to have it in order. Is it in order?
Yes.
Y squared minus 9y minus 22, yeah. Square, then just the y, then the number. That's what I'm talking about, in order. Is the first term positive?
Yes.
Good, because if it's not, we have an issue, all right? You have to have the first term positive. Next, we start counting the number of terms. How many terms do we have?
3.
Is this a diamond problem with a shortcut or a diamond problem where we have to use grouping? You can do the short. If you forget the shortcut, just do grouping, and that'll be fine. But you can do the shortcut here. In fact, this factors as, I told you I'm going to stop writing it all the time. This factors as y minus 11 and y plus 2. Can you verify that for me?
Yes.
You do a diamond problem, shortcut, we get exactly this. Do we stop there?
No.
No. With I remember me telling you this when I first introduced factoring. I said some people who have had this class before, they continue if I give them this problem. They start setting stuff equal to 0. Well, if I give you just the factoring, you stop right there. If I give you the equal to 0, that is when you use a zero product property. That's where you continue. So we would do, all right, y minus 11 equals 0. We would do y plus 2 equals 0. And we solve each of these. They're usually really easy to solve. They're at most 2 steps each. So we get 11, we get negative 2, and those are our 2 solutions. Where would we check those 2 solutions? In the factored idea or the very beginning?
Very beginning.
Very beginning. We check them right here to make sure that when you plug them in, they actually give you 0. Show of hands if you got 11 and negative 2. Good. I'll give you another hint. What's the largest power here?
Y squared.
So the largest power is?
2.
How many answers do we get?
2.
That always works. If that largest power is 3, how many answers will we get?
3.
4?
4.
And so on. That's a property of equations. So whatever your power is, that's how many solutions you'll be looking for. Now the only time that we break that rule really is when we have a double root where we get the same answer twice. That can happen. So it will be one answer, but it will show up twice. Okay, next one. Let's talk about that one. Firstly, is it a quadratic equation?
Yes.
Absolutely, it's quadratic. Do you see a power 2? Does that equal sign? That's the definition of a quadratic equation. Now, that's a different question than, is this written correctly? Is it written correctly? No, but it is a quadratic equation. I need to verify that for me. Did you see it's a quadratic equation? Okay, then you start asking the questions. Once you see it's quadratic, not right at the beginning, once you see it's quadratic, that's equation, then you start doing all the stuff I talked about. Is everything on one side with 0 on the other side?
No.
Happen. Make it work. What's wrong with this picture? Is this stuff good?
No.
No.
Yeah.
Oh, no.
What's wrong here? This is okay. This is wrong. I want this gone. How do I make this gone?
Add the 5x to the other side.
So that means x squared plus 6 plus 5x, right?
No, it's not enough.
No, it's
Oh. Do you notice that this gives you 0?
Yeah.
That's how you get rid of an entire term. You add it or subtract it. Why can't I have this?
It's not in order.
Factoring only works if it's in order. Factoring only works if you can do A, B, and C and get your A, B, and C right. So we have to have these. What I told you before is not irrelevant. It was very relevant. It was get your stuff in order. So when we're doing this, when we're adding or subtracting, yeah, our x squared comes first, then come any x's, and finally come the constants. Also, one big thing that students do, they mess this up a lot. They'll do weird things, like with minus 5x, they'll go so fast on tests, they'll subtract it again, and they'll give me a minus here. Is it going to factor the same way with a minus as a plus? So, your signs, bless you, your signs are very important, okay? Making sure that you have your algebra correct getting down to this part will ensure your factoring is correct. If you know how to factor and you F this up, if you factor this right up, F it up, then you're gonna mess this function up, or you mess this equation up. It's not gonna come out right. So your idea of getting everything on one side and in order is huge. It's all about adding and subtracting and making sure everything is all set up for you. Now at this point, check it again. Is it in order?
Yeah.
Yes.
Is everything to one side?
Yes.
Is our first term positive?
Yes.
That's what we want. Can you factor it?
Yeah.
Yeah, sure. In fact, this factors as the 3 and 2. X plus 3, x plus 2 equals 0. And I know that because I'm adding to a positive and multiplying to a positive, I have to have the same signs. It's the only way to get there. Did you get the 3 and the 2? Do we stop, folks? Do we stop?
No.
With the equal to 0, I go, oh, you know what? I got a product. It's equal to 0. That's the 0 product property. That's great. If I subtract 3 and subtract 2 respectively, I get x equals negative 3. We get x equals negative 2. And we get our 2 solutions like we should be expecting. Show of hands if you feel okay with the idea here. You may have made some mistakes. Okay, but I want to know if the idea is starting to sink in for you. That equations, everything on one side, in order, first term positive. 0 on one side, then factor. This is why we spend so much time factoring, okay? This is where we live for the first, quarter of our class. We live in factoring and equations. That's what we're going to be doing. So if you get this now, you're so money, it's been good. You ready to continue? Big numbers. Oh man, big numbers. Tell you what, I'm going to give you one to do in just a moment, but I want you to walk me through this. How you would approach this problem if I gave this to you on a test, because I probably will give you something very similar to this on a test. So how would you approach a problem? What's the first thing you're looking for in this problem? Very good. If it's a quadratic, is it a quadratic?
Yes.
Okay, because if it's not, we don't use this stuff. This is for quadratic equations. It is a quadratic and it's an equation. Verified equation for me? Okay, now what do you look for? Order. That's what you look for first? Equal to 0. That's what I would look for first, because moving stuff around is going to make it order or not, okay? So, is it equal to 0?
No.
That's a problem. What would, now listen, you've got to be smarter than the problem here. what would you do? Would you move the left stuff to the right or the right stuff to the left? The way that you answer that question, it changes depending on what your problem is. Let me show you something here real quick, okay? You're right, you'd move this here. The only reason why you would though is because your first term's already positive. If you had a negative here, please listen carefully. Put down your pencils now, some of you guys are working, stop. If that was a negative, there's no way you should move this way. You would move these two this way because you want your first term positive. Does that make sense? Are you positive? Okay, good. Even though it's it's another step, you're going to have two steps either way. You either, if for this example, you either subtract this and then change every sign, or you just add this and subtract the 4. Either way is fine, but this makes it a little bit nicer to make your first term positive right from the beginning. That way you don't get messed up on it. Okay, so first term is positive. That's why we're going to move the 29y by subtracting it on both sides. You'll notice where I put it right in the middle because I want to make sure it's in order in my head already. We get 25y squared minus 29y plus 4, and then we get equal to 0. We okay with that so far?
Yeah.
Okay. Now, what would we use to factor this thing? Why? Why would you choose a diamond? What would you check first before you even try to do a diamond? Is there a GCF? Not with the 29, it's a prime number. So now we're smoked as far as that goes. So no factor in GCF, but there's 3 terms. Is this a shortcut like we had before? No. This is why we learned factoring so well. So you look at this and go, I know how to factor that. That's easy. That's going to be a diamond problem. I'm going to do it for you pretty quickly, okay? That's going to be negative 25 and negative 4. Can you verify that for me? Negative times negatives are positive, add them together, you get negative 29. So if we were to factor this, we're going to have to do the long way, or use that trick that I showed you. Remember that trick I showed you? As far as dividing by your 25 here and here? You can do that if you want to as well. So 25y squared plus 20, no, my bad. Minus 25y minus 4y plus 4 equals 0. Don't forget to bring down that equals 0. You can still do that. All we've done here is broken one term into these 2 terms, 3 terms into 4 terms. Why do we do that?
So you can group them.
So if we do, we're going to factor out 25y, and we're going to get y minus 1. We're going to factor, what would we factor out here?
Negative 4.
Good. This forces you to factor out a negative. We get y, signs will change 1. I shouldn't have to explain why the signs change. I've done it very much. We have 2 big terms with a common factor of y minus 1. We'll factor that out, get 25y minus 4 as remaining parts of those terms equals 0.
You're not.
Why aren't we done? Why aren't we done?
Because it's set to 0.
Still an equation equals 0. And I'm asking you to solve. If you have an equal sign, I'm asking you to solve. I'm asking you to get down to setting each of these factors equal to 0, and then solving for y. That's what we want. So we get everything to one side. We make sure it's in order. We have 0 on the other side. The reason why we have 0 is so that after we factor all the stuff, we can do a 0 product property. If we don't have 0 here, this stuff does not work. Quick head nod if you understand that idea. Okay, so once we get down here, we set each factor equal to 0, and then we solve. Y equals 1 in this case because we're going to add 1. On this one, this is going to be kind of a nasty little fraction here. What are we going to do?
Add 4.
Is it a problem that we get a fraction?
Divide by 25.
The only problem is that when you get these fractions like this, and you get y equals 4/25, this number is really easy to check, all right? This one, not so much. That's going to be a bear, okay? Because you have this 4/25, you're going to square it, and that's just kind of nasty. Show of hands feel okay with that problem, all right. Tell you what, we're going to move on a little bit. I was going to give you one to do on your own, but I just want to know if you're okay with this idea. You get the idea? The idea is use your factoring, but if you're going to do that, you have to have everything on one side in order first. If you don't have it, then you're going to be wrong. Have I made myself real clear on that one? Okay, cool. So let's move on just a bit and do something like this. So y times the quantity y minus 4 equals 5. So when we're doing this problem, man, this is a nice, easy problem. This is a piece of cake. Watch how easy we can make this. Are you ready? We're just going to put y equals 5 and y minus 4 equals 5, and then we're done, right?
No.
No,
Wait, why not?
because it's not equal to that.
Wait, but you can't do that?
Mm-mm.
You ever hear that Taylor Swift song, Never, Ever, 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 Getting Back Together, Ever?
Yeah.
Well, you just sing Never, Ever, 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 gonna get this problem right if you do this, ever. That's how it really is supposed to go. I talked to her, and she said, yeah, I just wanted to make it more catchy. I said, you're a loser. You should go more that. Don't hate me, Taylor Swift. I know you're a very powerful person. Just joking about that. Can you ever do this? If she ever watches my videos, I'd be so impressed. Never, ever. You can't ever do that. Because why? Do we have a 5 product property? No, we have a 0 product property. This does not work, because you can find fractions that will make this work for an infinite number of possibilities, okay? The only time that you can ever take this factor equals this number and this factor equals this number is when you have what number here?
0.
Okay, so if you don't have 0, can you break up the factors like we try to do? Okay. Then what do we do?
You subtract 5.
Okay, if we do that right now, it's going to look a little funky. You might try to make this look like a quadratic you can factor. Because right now, basically what happened is someone messed this problem up. Okay, someone didn't subtract the 5 and tried to factor. Someone messed it up. So you're going to unmess it up. How we unmess it up is we make it look like something that you can do again. Ah, that looks better already. That looks like something we can manage. Are you guys okay with how to get that? Yeah, distribute it. Distribute it. When you have a non-zero here, make sure you distribute, because you're going to have to get everything to one side, which means you're going to have to combine like terms. You can't do that if you have not distributed. Okay, give me the next step. What do I do?
Subtract 5.
Subtract 5.
In the previous cases, we put this in the middle. Do we put the minus 5 in the middle or after the 4y? Why?
It's not in order.
Good. This stuff has to be in order. Let's double check. We had a 5, we subtracted 5. I know 5 minus 5 gives me 0. That's what I'm looking for. At this point, let's check it, okay? Do we have everything on one side?
Yes.
0 on the other side.
Yes.
The reason why we need it is because of the 0 product property. Is our first term positive?
Yes.
Got to have that. And it's in order, which is great. What would you do now? Factor it. Very good. Factor it. Diamond. With the long way or the shortcut? Love the shortcut. We know factoring diamond problems is going to give us 2 factors. We talked about that at length. Y is going to go here, y is going to go there. Can you give me the numbers that add to -4 and multiply to -5? Would you do that for me?
-5 and 5.
That's right, -5 and +1. So y minus 5, y plus 1, and then we just stop there, right?
No.
Why not? Why don't we finish?
Because it's equal to 0.
Yeah, it's an equation. It's equal, therefore it's an equation. Equations need to be solved. So with equations, we say, well, 0 product property, that's why we need the 0. 0 product property says every factor that you have gets set equal to 0, and then we solve those really easy equations. Add 5, y equals 5. Subtract 1, y equals -1. How many solutions do we get?
2.
Just like we thought we would right there. We okay with it so far? Okay. Tell you what, let's do, maybe do one. Just one on your own to practice it, because I want to make sure you guys get it. And then we'll end there for today. Okay, there you go. So check all this stuff. If something looks factored, that's great. But if something looks factored, it better be equal to 0 or it's kind of irrelevant. So if something looks factored and there's no 0 on one side of the equation, you got to undo that messed up factoring. Then follow the steps. Everything on one side, 0 on the other side. That's important. Make sure your first term is positive and everything's in order. And then factor. Okay, true or false? It'd be a great idea to set y equal to 4 right now.
No.
Really bad idea. Why not? That's not the zero product property. You have to have a 0 there to do that. So, what is a good idea?
Distribute the y.
Yep. Undo the factoring, how it looks. So if we undo the factoring, we'll distribute, and we'll have 2y squared minus 7y equals 4. Did you guys get at least that far? Okay, so you recognize, that's good. You recognize that the zero product property will not work, so we got to undo the messed up factoring. Now, after that, don't start factoring because you'd get right back to here. That'd be silly. Instead, recognize what type of equation this is. What type of equation is it? That word is what? Starts with quad, rhymes with radic. What is it? Quadratic. Yeah, it's a quadratic equation. So we see, oh, quadratic. Quadratic in your head at this point should go quadratic, everything on one side, in order. 0 on the other side. How we do that is we would just subtract the 4 right now. We got to make sure our signs are correct. Make sure everything's in order. And then we try to factor. So if we're going to factor, we have a negative 7, we have a negative 8.
Negative 8.
Negative 8 and what?
1.
1. So we're going to have x minus 4. We're going to have 2x plus 1. Did I do it right?
Y.
Oh, dang it. I'm glad you caught that. I want to see if you were paying attention. It's very common to do. It's very easy because we deal with x's all the time. Make sure whatever variable you start with, that's what you need to end with. Other than that, is the factoring correct?
Yes.
Do we stop there?
No.
So y minus 4 equals 0. 2y plus 1 equals 0. For the sake of time, I'm just going to do the work for you. We get 4 and negative 1/2. Show of hands if you got that one. That's really good. That's really good. Did today make sense for you? All right, so we're still in the middle of factoring and using that idea of factoring to solve equations. So, as I mentioned to you before we turn the camera on, we're going to go very fast through these next few problems. The idea that I want to get across to you is how to start them, how to set them up so that your factoring will be successful. At this point, I'm expecting your factoring is absolutely rock solid, like all the time. So the ideas have always been with our equations, if you have a quadratic, get everything to one side in order with your first term positive and factor. That's the idea. If you don't have a quadratic, well, you don't need to do the factoring. We talked about that last time too. If there's no power 2, then it's probably linear. If there's more than a power 2, apply the factoring stuff to it. But the idea is, in order for factoring to even make sense, there's one number, a special number that we have to have all by itself on one side of the equation every time. What is it?
0.
You've got to have a 0. If it doesn't have a 0, you have some work to do. I talked about a problem just like this last time, but the idea is, if that ain't 0, zero product property doesn't work because it's not 0. So, if that's true, your whole goal is to do what I've been talking about. Get everything to one side, in order, and then refactor it. Right now, the factoring, someone did it wrong. So when we distribute it, we got 3y squared plus 7y equals 6. And that already looks a little bit better to us. Now, would I choose to factor now, or would I choose to subtract 6 now? Yeah, if I factor, I'm going to get that back again. That'd be silly. I just got away from that. We don't want to do that. Why would I subtract 6 and not subtract these two? It is in order, but more importantly, say that again.
Positive.
Yeah, we want to keep that positive. If I start subtracting, it's going to change the sign. So let's subtract the 6, and we get our 3y squared plus 7y. We want to keep it in order. Minus 6 equals 0. This, ladies and gentlemen, is what every quadratic should look like before you start factoring. If it does not look like this, everything in order on one side, first term positive with a 0, do work to make it look like that. And that's the whole thing. That's really all of what this section is all about. Get it to one side in order with a positive and then factor it. 0 on one side. After that, not even a problem. We can do, what would we use here? That's 7 and negative 18. That's negative 2 and 9. Can you verify that for me? Okay, if I divide by 3, we get 3 over 1. That means our factors here are 3y minus 2, 1x plus 3 equals 0. Can I get a double check to make, oops, made a mistake. Can I get a double check to make sure that's right? Could you double check your work here if you wanted to? Yes, no?
Yes.
Let's see if I'm right. Does that give you the 3y squared that I want?
Yeah.
Does this give you, here's 9y minus 2y. Does that give you plus 7y? Yeah, 9y, okay. And then we have a minus 6. So that's the correct factorization. You'll notice I did the shortcut. I didn't factor by grouping. I did a shortcut here. I don't care what you use at this point. I give you two methods, right? Use either one. I don't care. If you like to split up and do grouping, great. That would be the other way to do this. At this point, do we stop? Do we stop here? No. This is where we use the idea that if that's 0 and we have a product, I can use the zero product property, write both of my factors or all of my factors equal to 0, and then solve them. If we add 2 and divide by 3, y equals positive 2/3. If we subtract 3, y equals negative 3, and we get our two solutions. Show of hands feel okay with that one. Okay, like I said, now we're going to start moving fast through this. Essentially, I just want to give you the first steps. I will work through them all, but I really want you focusing just on the first steps to make it look like this. So, let's try that. Negative 5x squared plus 20x equals negative 60. Number one thing you check for is quadratic. Is this a quadratic? Yeah, what lets you know it's a quadratic?
The square.
Perfect. Yeah, that's exactly right. Okay, when we have a quadratic, we want to get everything to one side.
Yeah.
Is everything to one side?
No.
That's a problem. We also want the first term positive, so you tell me. Would it be best to move the negative 60 to the left or these two terms to the right?
Right.
Yeah, really, that would be it. Now, could you do it the other way? Yeah, sure. Here's what would happen, okay? Check this out. You have options. I really don't care as long as you maintain the in order first term positive. That's got to be the case. If you wanted to add 60 here, so here's option number 1. If you wanted to add 60, we would get negative 5x squared plus 20x plus 60 equals 0. Can you follow that?
Yes.
Okay. Now, that's not going to work real well for factoring because that's a negative and that's going to mess up my diamond problem. That is not going to be good. Does that make sense to you? So, if that's the case, here's one thing that you can do. You use that negative like a GCF like we talked about and factor out that negative 1. Essentially what's going to happen is that you're just going to change every sign. That's all that's going to happen here. So if we have negative, we get 5x squared minus 20x minus 60 equals 0. Does that make sense?
What's your GCF though? 5.
Oh yeah, okay, well, you're right. I'll focus on it in a minute. And I just wanted to get to the point of they're going to be the same on both sides. So just focus on me for a second, okay? Here's another thing. If I divided by negative 1 on both sides, 0 divided by negative 1 is still 0. Negative divided by negative is positive. Essentially, that negative doesn't do anything to us. We can completely get rid of it. So if you want to do it that way, get everything to one side, and then if the first term's negative, just divide everything by negative 1. That's fine. That'll change every sign. That's okay. If you would prefer, and this is the way I like to do it, option number 2, I like to start here. And instead of having to factor and divide later on, I just like to add over the appropriate thing. So if we have negative 5x squared, I know that that's my first term and I don't want it negative. So if we choose to just add these and subtract these terms respectively, add 5x squared, subtract 20x, and just do it to both sides. Add 5x squared and subtract 20x. Then we get 0, it's just on a different side. 0 equals 5x squared minus 20x minus 60. Do we end up getting the same thing here that we have here? Yeah. Does it matter what side of the equation it's on? Equations go back and forth, they don't care. So as long as we have in order, first term positive, and 0 on one side, we're good. Whatever way you want to do that, I've now given you 2 ways. Quick head nod if you're okay so far. Okay, now the reason why, and you're absolutely right, here you would probably factor out negative 5. You guys see what I'm talking about? So if you did it this way, yeah, factor the negative 5. It's going to be the same number of steps. Here, we'd factor out negative 5 or positive 5. But we still do the same thing. So let's go ahead, let's continue. So if we factor, Now remember that when we do this, when we factor, you're always doing the same thing. You never ever skip the first step, which is when you're factoring GCF. Always check for GCF. Here, if you factor out the 5, tell me what I get when I factor out 5, please.
X squared minus 4x minus 12.
Does it matter that these signs are the way they are? If I change the signs, does it change my problem? So doing all this work, you got to be really good at it to make sure that your signs are correct. Okay, what would I do now? Say what now?
Diamond.
Diamond problem. Okay, can I use a shortcut on this diamond problem?
Yes.
Yeah, that makes it nice, because here we couldn't, but factor out the 5, now we can. So if we factor, we have 5. We'll have x minus 6, x plus 2. You can verify that on your own if you'd like to. Am I done?
No.
Now, I mentioned something, I don't know if I explained it very well, but I mentioned something here before. Here's the thing. How many factors do we have? We actually have 3. How many factors include variables?
2.
Only set the factors that have variables equal to the 0. The 5 equals 0, it's irrelevant. It's a nonsensical statement. It won't work, okay? So set this x minus 6 equals 0, set the x plus 2 equals 0, and then just solve those ones. So all the variable factors, set those equal to 0. Therefore, x equals 6 and x equals negative 2. Okay, what I'd like to know is if both of these ways made sense to you, or at least one of them. That's what I want. At least one of them makes sense. Show of hands if you feel okay with that one. Questions? Are we good? Any questions at all before we continue? So,
What do you do with the 5? Yeah.
nothing. No.
So nothing you factor out goes into the equal to 0.
Just one.
Use the 5 to check.
Of course you have to. Well, okay, now listen. This 5 doesn't give you a solution at all. There's no variable associated with that. So the 5 here, you're not going to set it equal to 0. It's not going to do anything for you. Now, of course, when you check your work, now you guys can be good enough at this. You're not going to check it here. You're not going to check it here. You're not going to check it here. You're going to check it here. At the very original problem. Does that make sense to you? If you check your work, it's got to be here. The 5 is incorporated there. So the fact you factor out here doesn't matter. It's up here for you anyway. So that 5, this factor of 5, it's not changing our answers. It's not changing that. You could have got the same exact answer if you had negative x squared plus 4x equals negative 12. Same thing. Exactly the same. That's just kind of interesting.
So if we would have factored out like a 5x, then we would have had to...
Can you factor out a 5x?
So I'm saying like if we would have...
If that was an x cubed and that was an x squared and that was an x, then you'd have a 5x there.
And that would have been...
That 5x would have to be equal to 0 because that's a factor that includes x. Does that answer your question?
Yeah.
Okay, so factors that include x, set them equal to 0. Factors that don't, it doesn't do anything for you. Let's practice one more because I can tell that this isn't quite sunk in yet. So here we go. Firstly, one thing I want to make sure that you're clear on, do you understand that I cannot start factoring now because I don't have everything to one side? You guys get that?
Yes.
Okay, I'm not going to give you another problem exactly like this. It'll be similar to this. Okay, we're going to have to move a little quick on this problem, but we'll pause on the first few steps because I want to make sure you guys get it. Okay, so first thing we always check is, do we have a quadratic?
Yes.
That means that sometime we're going to factor. If we don't have a quadratic, if the power is less than 2, like linear, don't factor it. That's silly, okay? But if our power is 2 or more, you're going to be factoring in this class for now. We have a quadratic. Is everything to one side?
Yes.
That's great. That's great. Are we good? Should we factor now?
No.
What's the problem?
The first one's time.
Yeah, it's in order, but our first term's negative. So we're essentially at this point. Now you can choose again to do 2 things. You can't choose to factor. That's the one thing you can't choose to. You can choose to subtract 72 and add 6y and add 3y squared and move it all, or you can choose to factor out a GCF. and that GCF has to include a negative in this case. Does that make sense to you? So if there was not the 3 that divides all 3 of those terms, you just factor out -1. In this case, what are we going to factor out? -3. Yeah.
-3.
If we factor out the -3, we get what?
Y squared plus 2y.
So glad you caught the plus, and then?
Minus 12, 26.
Minus.
24.
Minus plus? I don't know what that one is. What is it?
24.
Okay, I care more about the minus
Negative
or the plus.
24.
Minus 24.
Let's double check that. Do you all understand why we factored out a negative here? Why we did that?
Make it positive.
Even if the 3 didn't go in, do you understand that we still would have factored out the negative like I showed you here? Do you guys get that? So no matter what, you got to make sure your first term is positive. You do that in one of 2 ways with equations. With equations, you either add or subtract, or you divide by, or factor out a -1. That is dividing. Divide by -1. That's how we clear that first term being negative. Quick head nod if you're okay with that so far. All right, so we clear out that negative. Now, next up. Are we done? Now, can you factor this? So we should. If we factor it, what do we do with that -3? Do we do anything with that?
No.
Just leave it there.
That's
Make your first term positive, that way your factoring actually works. If we do, it's a shortcut problem, it's a really easy problem. It's going to be 6s and 4s. In fact, it's going to be +6 and -4. Can you check that for me, please? +6, -4. Now let's all think about this. Does the zero product property work?
Yeah.
Yeah, we have a 0. It is a product. Now listen carefully. How many factors up here include variables?
2.
Is this set equal to 0 going to give me a solution?
No.
No. And if you did it on a test, if you gave me a solution, you should check it. Because if you plug in -3, it's not going to work at all. So if it had been this, you had a 3y right there, then yeah, -3 would equal 0. Every factor that has variables uses 0 product.
So in other words, it's not really. It's kind of irrelevant to the answer we're going to have.
This -3?
Yeah.
Absolutely irrelevant. This will have the same solutions as this. Now, what's interesting is this and this will have different graphs, but where they cross the horizontal axis will be the same. That's what you're finding here. I kind of don't talk about this until chapter 11, late chapter 11. What these are, what quadratics are used. They're parabolas. That's what that is. Upward shape or downward shape. And what we're doing is finding out where these things cross a horizontal, typically the x, not here because we have a y, typically the x-axis. And so what's happening is that this graph looks like this. This graph looks like this. Where they cross the x-axis is exactly the same. That's really interesting, but that's what we're doing. So the solutions are the same, it's just that this one is manipulated a little bit. Everything's being multiplied by -3. It's reversing the parabola, it's changing some of the parameters about it, but the intercepts will be the same. So what I'm trying to tell you is, if it doesn't have a variable, it's a really long way to say, if it doesn't have a variable, don't set it equals 0, and you get the same coordinates anyway. So y plus 6 equals 0, and y minus 4 equals 0. Y equals, what's y going to equal?
-6.
Oh, and
Positive 4.
how many solutions?
2.
2 solutions. Same solution. Show of hands feel okay with that one. All right. Let's do another one. You know what? I'm going to change it. I don't want to do 2. It's going to be 2 the same, almost same thing. Okay, you all know the order, so I'm going to go through it really, really fast with you. First thing we check for is, do we have a quadratic? Actually, do we have a quadratic here?
No.
It's bigger than a quadratic. What that means is you still do the same thing, but you're going to be trying to get a quadratic out of it, okay? Otherwise, we're going to have a really hard time doing this problem, unless it happens to be a sum or difference of cubes. So, it's a quadratic or higher. Is everything on one side?
Yeah.
That's great. Is our first term positive?
Yes.
That's great. Now you start factoring. Everything on one side, zeros on the other side. First term's positive, that's great. Then we factor. Everyone in the room right now should know what's your first step in factoring every time. Do we have a GCF besides 1?
Yes.
3y. Do the number 2. 3y. I think this probably would have answered y'all's question from before, right now anyway, but here you go. So factor out the 3y. Okay, tell me, what's the first term?
Y squared
And then?
minus 4.
Perfect. Hey, true or false? We're factored completely. Time to do zero product property. Don't do that to me. You guys have come so far with factoring. Factor completely before you attempt to do this stuff. Does that make sense to you? Factor completely. Is this factored completely? This.
Yes.
This?
No.
Factor that. So leave the 3y. Yeah, and you know what? After all your practice on the homework, you're probably really good at doing those, huh? Yeah. It's a difference. That's a square, that's a square. This is 2 squared, so we do y minus 2, y plus 2. I want to know if everyone's okay with getting down this far. Show of hands if you are. Notice how this is exactly the same as stuff we've done before, just without the equals. Now that I have the equals to 0, it's just one more step. It's a zero product property. Now, how many factors do we have?
3.
Technically, you have 4. 1, 2, 3, 4. But you're just going to group that together. That 3 really isn't going to do a whole lot. But you can group it with this. Consider that to be 1 factor, 2 factors, 3 factors. Every factor that has a y, you set equal to 0. Now check this out. Do you remember me telling you something about how that negative 3 really doesn't matter?
Yeah.
How the 5 really doesn't matter?
Yeah.
Because it's just a multiple, it's just a factor of a constant number, okay? Check this out. Watch. If I don't put the 3 here, if I just do the y, if I just do the y equals what?
0.
Oh, but wait, now let's put the 3 there. What's y going to equal?
0.
Are you starting to see what I'm talking
Yeah.
about? That multiple of 5 doesn't matter. It does not matter. It's set it equals 0. If it's just that factor of a constant number out front without a variable, that's not affecting the answer. It's not affecting our solution. Did I make my point here for you? Okay, so probably it's going to be easier for us to understand if we just set that equal to 0. That's fine. Let's just divide by 3. You're still going to get 0. You with me? Now the other ones, we have y minus 2 equals 0, and we have y plus 2 equals 0. Therefore, if I divide by 3, y is it okay to divide 0 by a number?
Yes.
Is it okay to divide a number by 0?
No.
Okay. So this is 0. Then we get y equals 2. We get y equals negative 2. And wait a minute, how many solutions do we have?
3.
Ah, it's not a coincidence. It happens all the time. It's interesting, right? It's cool. To me, that's cool. I like that. Am I making sense to you? Okay, this one I actually want you to try. So I'm going to put one up on the board, go through the whole process. I want you to verify that it's a quadratic or higher. Everything to one side, first term positive in order, and then factor and use zero product property to solve. This would be a good opportunity for you to treat this like a test. Did you catch that hint? This is going to be on your test. Did you catch that hint? Okay, here we go. It seems innocuous enough, very simple. There's a lot to the problem. Do it all right. Let's see if you can get it. By the way, you're finding solutions here. How many solutions would you expect to get on this problem just by looking at it?
3.
Very good. Could you check them?
Yes.
You would not check them in any step past that one. That's where you check solutions, just to make sure you have everything right. So if you're going to check them, check them. I can already tell you one solution right off the bat, 0. Can you see it?
Yeah.
0 and 0. And you're going to get that because when you get this on one side in order, I'm going to jump ahead of myself, but there's a GCF, and the GCF includes x. When you factor the x out, ultimately you're going to have that x equal to 0. You're going to have a solution of 0. So let's see how that works. I check quadratic or higher. I have it. It's a power 3. That means I'm going to try to get a quadratic, or I'm going to use sum or difference of cubes. Now that's not this case, but that's what you think. Next up, if it's a quadratic or higher, everything to one side. I don't want to move this to the right because that's positive, and I like my first term being positive. I would subtract my 63x. And then get 7x to the third minus 63x equals 0. That's great. That's everything on one side because it's a quadratic or higher. That's the first term positive, and it's in order. And then I start looking for all my factoring stuff. Everything that we've done this whole semester so far comes into play here. It's, well, I've got 2 terms. Do I have a GCF?
Yes.
Make sure it's the GCF, not just x, not just 7, the whole thing, the whole 7x. So if I factor out 7x, I get x squared minus, and this just became a really easy problem for us, because this becomes, man, if you have done your homework and you know about difference of squares, that's a piece of cake. We keep the 7x, we go, hey, can I keep factoring x squared minus 9?
Yeah.
Yeah.
Should I do zero product property yet? No, not until you have it factored. We get x minus 3, x plus 3, because it's a difference of 2 squares, that's 3 squared. First thing first, last thing last, different signs. And now we double check. Is this completely factored? Yeah.
Yeah.
This one? Yeah. This one? Yeah. How many factors include a variable?
3.
And you have 3 things equal to 0. We have 7x equal to 0. We have x minus 3 equal to 0. We have x plus 3 equal to 0. And if we do some very basic math, x equals 0 by dividing by 7. X equals 3 by adding 3. X equals negative 3 by subtracting 3. Our 3 solutions are there. Can you do it? I think you can. As long as you have, it's easy as long as you know factoring and zero product, and that's the only thing I'm asking you to know. That's it. Tell you what, we're going to do, we'll do 2 more. I'm going to do one with you. I'll give you one to do on your own, and that will solidify everything that we know about now solving equations with factoring. After that, we're going to step it up to word problems. Yay! Yay?
Yay.
Yay. Right? Right?
No.
Yay! Lie to me. Yay.
Yay.
I can teach it. Can you learn it? You can learn it. You know, a lot of times it is, can the teacher teach it? But more times it is, can the student be, no, you can all be taught. Will you have enough perseverance to actually make it through it? Will you do it? Will you do it? Because for some people, math is easy. For some people, math is hard. For the ones who have it easy, you got it easy. For the ones who it's hard, you need perseverance. And you really, everyone can learn it, okay? Unless you, well, not everyone can learn it. You all in this room can learn it. But it takes a lot of practice for some people. Just be prepared. Okay, so, what in the world is going on with this problem? Let's take a look at this, all right? Number one thing, is it a quadratic or higher?
Yeah.
Yes.
If you distributed that, it's actually cubic. Did you see it? It's power 3 if you did it. Should you distribute it?
No.
Let's think about that. Do we have everything to one side?
Yes.
Is 0 on the other side?
Yes.
This is different from one of those problems before that was like y and 3y, like the opening of the class. Remember this one? Where is equal to 4? Remember that? Now listen carefully because this is going to blow your mind, all right? Check it. If this was 0, would I have had to distribute that?
No.
If that was 0,
No.
I would have done y equals 0 and 3y minus 2 equals 0, and I would make the problem easy. Does that make sense? Okay, so if that's 0, the work is done. If that's not 0, That's why we distributed and got everything on one side. Do you see the difference? Tell me something good about this problem.
It's already, you have two terms.
I have two terms, but more specifically, what's it equal to?
0.
0. I have two factors, and they're equal to 0. Do you notice that the zero product property does apply here? I have this thing times this thing equals 0. Here's what's happened. This is an easier problem. Believe it or not, this is an easier problem. Someone's actually done half the work for you. Someone started with the distributed version and factored out some of it, and then they stopped. Can you factor this any further? Let's check to see if you know how to factor. Can you factor this any further?
No.
Can you factor this any further?
Yes.
Then just do it. It's already equal to 0. This is nice. This is a good one. So just factor this, and then you'll have your three factors. Does that make sense to you? Don't distribute unless you have to. Here's why. If you distribute this right now, you're going to get a y to the third power, and I have not taught you how to factor y to the third powers in general. I've given you very special cases when they group and when it's sum or difference of cubes. This is not one. So if you distribute this, that's the wrong road. What you do is this. Just like I told you, is everything to one side with 0 on the other side, and then you factor. It's already started. It's already factored. So as I've been gabbing on, you should have been factoring. I hope that you were, not just listening to me, my drivel here. So if we do that, can you think of numbers for 13, negative 13 and 30? Yeah, that's what I got. I'll show you the long way this time, just for funsies, nostalgia. 2y squared minus 3y minus 10y plus 15. Now, right now I'm not putting the equal to 0 because I'm going to put the factors back up here in just a moment. I factor by grouping. And we got it. Here's what this changes this problem into. Did I change this factor?
No.
Did I change this factor?
No.
But it's still there. Did I change this factor?
Yeah.
This one.
Yes.
In fact, that's what all this work was. So this has two factors in it. 2y minus 3 and y minus 5. And then we have it equal to 0. If you get that whole idea about all this stuff, show of hands if you feel okay with that so far. Do you? Okay, so we have zero product property. That's cool, but it's not factored completely. So it's equal to 0. That's great. Just finish the factoring. If we finish the factoring, now what should I do? Should I stop right here?
Set them all equal to 0.
How many? How many is all?
3.
3 include variables, so set 3 factors equal to 0. If you add 2, divide by 3, add 3, divide by 2, and add 5, we have 3 solutions that all work. Are they going to be easy to check? Not so much, because fractions are kind of hard. So on some of these, when you get those fractions, you better make sure your work is pretty good, because it's really hard to check them. I want to know if I've explained everything well enough for you guys to understand it. Have I so far? Would you like to try just one more to make sure that you get it? Okay. There you go. A little different. I'm not going to give you another one just like that. I think that we've mastered that. Are we good with this one? And that you just need to continue factoring. Before I move on, are there any questions on this? You guys okay with the idea that it's a 0, so we're good? Just continue factoring and set those factors equal? Are we okay with that one? Question?
Okay, so right here with the 3y minus 2 equals 0, if it were just the 3y near the parentheses, you wouldn't have to do the fraction, right?
I don't understand what your question is.
Underneath the arrow there where it says 3y minus 2,
That's from here.
but what I'm saying is, for example, if you had the 3y on the outside of that by itself, it would just be, the y would be 0, right? Instead of doing a fraction.
Okay, what would happen to the negative 2, the minus 2?
You would add it.
Okay. The only time that you're going to get that is if you have only one term there. In this case, you wouldn't even need those parentheses. And then what you're talking about, we've already covered that. Okay? As soon as you have this minus 2 or anything, that's grouped into one factor. You can't separate that by itself. You have to set each of those factors equal to 0. Hopefully that answered your question.
Yeah.
Okay. I'm right. Okay. Is this the way you like to see an equation?
No.
Sometimes, if it doesn't have any powers in it, yeah, cool. But this does. This has more than a power 2, which means everything to one side, right now it's not, we subtract the 12y. We make sure everything is in order. As soon as you have in order, first term positive, and a 0 on one side, you're money. You're good to go. Now we do factoring and use every trick in the book that I've taught you for factoring. First thing we do here is do what?
GCF.
GCF is,
3y.
and if I factor that, I get y squared.
Minus
3y minus 4.
That just changes a hard problem into a really easy problem. It's nice, as long as you check for GCF. Can you explain to me why I care so much that you know about GCF? Because I've been hammering at that. Can you explain why I did that? Makes it easy, yeah. If you don't do the GCF here, how are you going to do that problem? I have no idea. I don't know. You have to do the GCF to be able to do this stuff. It makes your problems just very quick if you always check for it. Don't neglect it and you'll be fine. Do I stop here?
No.
No, this is essentially what we had in the last problem where we had those two large factors. This one is actually what you were talking about a little while ago. What if there's no minus 2? That's the same thing. It's like it's already halfway factored for you. There's just no minus 2 here. This is going to be set equal to 0. Just continue factoring. If we do, this is a nice shortcut. It's not a long one. Here's y, here's plus 4 and minus 4 and plus 1. Let's double check it. It works. We'll have 3y equals 0. We'll have y minus 4 equals 0. And we'll have y plus 1 equals 0. Because we got those three factors, each of which has a variable in it, that we need to figure out a solution for. If we do some very simple math, basic math, we get negative 1, positive 4, and 0. Why do we get a 0 and not a 3 there? What happens? Dividing 0 by a number, you still get 0. Show of hands if this is very clear to you at this point. We just finished factoring and using them for equations. Now, the next thing